Today we will discuss contour integrals. I will write it. Like integration, we will discuss how to do the integration of complex functions. So the topic is integration of a complex function along a contour. Integration of a complex function integration of a complex function is what we have to discuss along a contour. Con, con, contour. Contour. Yeah. So what it is, like, let us get the idea of that. Then it will be very easy to understand once we get the idea how to do this. So first we have to understand what is this contour. Yeah, I will pronounce it as contour. So what it is exactly, let us first try to understand that. Then we will understand how to integrate that contour. So basically, if I talk about contour, so we have a surface in a plane or 3D also object if we have, we can break it into planes because planes make up the 3D object. So what is a contour? Contour is basically a continuous chain of finite number of lines or finite number of smooth arc. Line, we will not say, we will say arc. And what is the difference between a line and arc? That we will discuss. First, I will write the definition, like the meaning of contour. First, I will write. Then we will discuss it in detail. So what is a contour? Contour is a continuous chain of a finite number of smooth arcs. Continuous chain of a finite number of smooth arcs. Now we can understand it, like the meaning of it. See, the idea is that the difference between the line and the arc is that line has to be straight and arc can be anything. It can be any curve. This is an arc. This is an arc. Okay. So the difference between the line and arc is clear to us. Now, what is a contour? We know that any surface you take, any curved surface you take, it is, we can say that it is made up of continuous lines. So that we call it as the contour. Like let us suppose I have a 3D, which is like something like this, a pump kind of. So this, it can be made up of single lines. The surface of, and they are very close to each other. This is what is we call the lines, the arcs, not the line but the arc. So the arc we have, those arc we call it as the contour. So the idea is very clear. If I have to integrate this surface, I just have to do the line integral of these contours, because line integral will give me the summation, and
Yes, sir.
all the summation I will get the area of this. That is the main idea. Of contour. Now we can discuss some more topics, some more points about contour. If a contour is closed, if a contour is closed, and does not intersect itself, so I have a closed contour which is not intersecting itself, then it is called as the closed contour. Then it is called as the closed contour. See, what it means, like visually, the visualization of the closed contour will be something like this. If the arc, after all its, like the wherever it is going, if it comes back to the initial point, if I have an arc like this arc I call it as the closed contour. So the arc which is closed means the initial point and the final point, they intersect, they merge with each other. That is the closed contour.
Yes, sir.
And yeah, and the same surface which we draw, we can, so this I have, this is not a closed contour, but it is an open contour, because the arc, they are not closed. But similarly, yeah, I can have a closed contour also. That's possible. The similar bump we have, let us suppose, like it is a 3D. Now, when we look it from the top, we can say that from the top view, we can say that it is made up of like these circles, like not perfect circle, but something like that. So the contour now we are getting, that contour is basically the closed contour. Something like this. The bump will be, so it will be a closed contour. So idea of closed contour is clear to us. The objective of this topic which we are learning is to basically how to integrate these contours. Now let us see how to integrate this. So now we will discuss contour integral. Contour integral. and we call it as line integral also. We call it as line integral. So let us discuss this. So let us suppose we have a contour which we are representing it with C. So we have a contour, capital C, and it is parameterized because the contour, that contour I can represent it mathematically via a mathematical function. And let us suppose the function is something like this. Zt is equal to xt plus xt plus I by t. So let us suppose this is the function, the complex function which is representing a contour C. Because we are doing the complex analysis, so the plane is complex plane, and hence the function will be a complex function, and hence it is having a imaginary term. And let us suppose this function is defined for an interval, and let that interval be the t which it is lying from a to b. Okay. Now the line integral or the contour integral, what it is? It is basically the integration of this function f of z along dz. Yeah. So the count. So this will be the line integral or contour. Now let us see how to calculate this. The basic idea. Let us look at some questions. Evaluate contour integral C for z conjugate dz. And here x is 3t, x is given, y is given, and the interval is given. So in the question, you will be given something like this. You will be asked to do the counter integral, because this in the integration, this capital C, it indicates the contour integral, and you will be given some x and y and you will be given an interval in which the t will lie. So you will get questions like this. Now we will see how to solve this, the approach. So first, whatever x and y is given, based on that we can get the equation of the contour. Because equation of the contour, we know that it will be z is equal to x plus iy. So according to this, the equation will be z of t, because x and y both are function of t. So the z, the contour, the equation of the contour, it will be a function of t, and it will be 3t plus iy. It will be 3t plus I. Sorry, I t squared, 3t plus I t squared. Instead of x, I have substituted 3t. Instead of y, I have substituted t squared. Now what I can do, I can plot it. I can plot this arc, this contour. I can plot it along a complex plane. So let us visualize that.
We have to make the diagrams also in these questions.
If you can make, please make it. Like if you feel like it's simple, you can.
Okay.
Here we can very easily make it, and hence we are making it. So the concept is very simple. See, once we got the equation of the contour, now we can just substitute two values, 0 and so z of 0 will be, so when z will be 0, the point I will get will be 0 comma 0. No, no, no. Yeah. Just let me extend it to the negative direction. The graph we will be making, it will be having negative. Just let me make it proper. Let me draw a straight. Yeah, now it's proper. Hmm. Now let us try to identify the points. Because the equation we know, zt is equal to 3t plus it square. Now we are trying to plot it in the complex. So this is the complex plane, wherein this is the real part, this is the imaginary. I can write imaginary. Now how to plot it? Now let us try to understand. Now see, I have to do z0 and z. Just one. Okay. So I have to make use of this limit -1 to 4 because the t can lie from -1 to 4. So first I can take the minimum as -1, then I can take the maximum as 4. So what I'm trying to say is, in order to find the point, first I will take t is equal to -1. When I do that, the equation just substitute t is equal to -1 and you will get -3 plus I. And once again, for the another point, we are trying to find the extreme points. So one is the -1 and the maxima is the 4. Like the extreme point in the right hand side, that is the 4, which the t can take. So when I take t is equal to 4, just in this equation, we can substitute t is equal to 4. So we will get 12 plus I 69. I16. Now we can plot this. So we for first point we have the coordinates -3, 1. So when t is -4, t is -1, we have -3, 1. So -3 will be somewhere here. 1 will be somewhere above. So this can be that point. So first point we got. I can write it -3, 1. Similarly, the another point is 12, 16. 12 I will get somewhere here. 16 somewhere above I will get. So this is the second point I got.
We have to just keep -1 and 4 in the equation and we'll get the points to plot on that.
Yeah, whatever interval is given. In this question, the interval is -1 to 4. Whatever interval will be given, the left extreme value, put it to get 1 point, right extreme value, put it to get another point, and just draw the points and like merge them. Welcome. And why we are not directly merging it, we are taking it from 0 because t can be 0 also now. And when t is 0, this function can take 0 as the value, 0, 0. So 0, 0 is also 1 point. You can take one more point, that is take t is equal to 0 in this equation, and you will see that 0, 0 is also one more point. And hence this contour, which is an arc, this contour which is an arc, it is passing through the origin. It is passing through the origin. Now our goal is that, okay, we have visualized this contour, we have the mathematical equation of this contour. Now our goal is to integrate this. And when we will integrate it, ultimately we are finding the length of the contour. The line integral we will do. So let us try to do that. So how to do this? Let us see. So this is now basically in the question they are asking the question. If you look at, they are asking integration of z complement. So whatever like not complement, conjugate. In the complex number there is a concept of complex conjugate. Whenever we calculate the complex conjugate, the sign we change. If it is plus, we make it minus. So the complex conjugate will be 3t minus it square. Right? We have to integrate that. Let us try it. So integration of complex function, complex conjugate dz. This will be equal to integration complex conjugate will be 3t minus it square. And dz we can calculate. Dz will be like just we have to differentiate it with respect to t. So 3 plus 2 it. 2 it dt.
So how?
See, whatever z we have to differentiate the z with respect to t. Dz by dt.
Yeah.
So dz by dt will be 3 plus 2 it, and dt I can take it this side. So dz will be this. So instead of dz, I can substitute 3 plus 2. Now what I will be doing is line integration. Like I can multiply the both the terms. Then I will get something like this. 2t cube. After simplification, you will get 2t cube plus 90. 90 plus 3t square I. This I have to integrate with respect to t. And for the t, the integral limits is -1 to 4. Now I can solve this. So it will be 2 c to the power of 4 by 4.
How will we integrate?
Yeah, with respect to t. Plus 9 t square by 2. T cube by 3 with the I. And you can just put the limits.
I will act as a constant.
Sorry.
I will act as a constant.
Yeah. I will be the. I will say that it's the imaginary part. Yeah, it will act as a constant. That is right. While integration. So after simplifying, you will get 195.
So we'll cut the 2 and 4. We can cut, right?
We can.
2 and 4 and 3 and 3.
Yeah, we can. 2 ones are 2. Yeah, that is. So this is the
Final
answer.
answer. Yeah.
Yeah, after putting the limits, if you can cross check it, then you will. So this is the line integral for this function. So this is how we will be doing the complex integration. Okay. Let us do one more question. Let us do one more question. So the function is the function given to us is a basically a we have to find the line contour. Line contour we have to find the of 1 by z. This is what we have to. And this the contour is a circle and x and y is given in the question. All this will be given. X and y will be given. So x is cos t. X given is cos t. Y given is sin t. And the t is from 0 to 2 pi. T is from 0 to. Okay. Now we can try this. So first thing is to get the equation for the contour. So zt is equal to x plus iy. So cos t plus I sin. Now we can visualize it very fast. Visualize. So we have the real axis and imaginary axis. Now the t it is from 0 to 2 pi. So what we can do is we can get the value, the points at 0 and the points at 2 pi. So at 0, cos 0 is 1, sin 0 is 0. So cos 0 is 1. So we will get 1. 1 plus 0 and 2 pi. You know what is cos 2 pi?
2 pi means 360.
Yeah. Pi by 2 pi 3 pi by 2 2 pi. Okay, cos 2 pi is 1. And the sin 2 pi will be 0 from the graph. 0 to pi by 2 pi it is 0. It means that okay, I am getting the same 1 comma 0 as the point. in between I can take pi also, because 0 to 2 pi I can take any t. I can take z pi. Oh, okay, pi also the same. Okay, but cos pi is -1. -1 plus 0. And we can take pi by 2 also. 0 plus 1. So these are the points which we got, and we can now visualize it. So 1 comma 0. X is 1, y is 0. So this is the 1 comma 0. We have -1 comma 0.
Again 1 comma 0.
Again 1 comma 0, the same point. Then we have -1 comma 0. X is -1, y is 0. Then we have 0 comma 1. X is 0, y is 0. And you can take 3 pi by 2 also. So you will get this 0 comma 1. And when we just, because it is an arc, so we have to
So after
merge.
3 pi by 2, what are the points?
Yeah, I will write. See, for this 3 pi by 2, cos 3 pi by 2 will be cos pi by 2 0. And the sine 3 pi by 2 will be -1. So 0 -1. So 0 comma -1. Now when I will merge it, since it's a curve, it will be something like this. Then this. Then this.
Circle कैसे?
Circle, it will be a circle. It will be a circle. So this is the contour, and it's a circle, and hence it's a closed contour. Now we have to integrate this. How we can integrate this? So integration of C 1 by z dz, it will be equal to, we have to integrate it. Okay, so dz also we have to calculate. Let us calculate. So see, dz will be just differentiated with respect to t. So differentiation of cos is minus sign. Plus I cos t dt. And so I can write it 1 by z. Okay. And here I can
1 by cos t into
like one
dz.
Yeah, 1 by cos t plus I sin t into this cos t
minus sin t.
minus sin t plus I cos t. Yeah, so this is one way, but we can apply here one jugaad, we can say, that technique. Let us do that to simplify this. So this also you can do, but the complex will be very the calculation will be very complex here. One jugaad we will apply. We know that, always remember, cos theta plus I sin theta. One property I'm using, I'm writing it here, this property, very important property. You should remember this. Property says that cos theta plus I sin theta. It is equal to e to the power of I theta. So whenever we have cos theta plus I sin theta, I can write it e to the power of I theta. So according to this property, I can write zt as e to the power of it, and according to that,
T
dz
will be T
t e to the
e to the power IT.
dt. Now it has become so
So
easy.
लेकिन अगर हम cos के फॉर्म में लिखते cos sin के तो कुछ कटवट नहीं जाता है.
नहीं,
So
कटता
reduce
नहीं.
होता है.
या बिकॉज पहला टर्म आपका माइनस साइन टी प्लस आई कॉस टी है, तो उसका फिर आपको वो कॉन्जुगेट क्या कहते हैं, रैशनलाइज करना पड़ता.
Yes sir.
मतलब कुछ स्टेप्स आपके एडिशनल होते हैं, बट यहाँ पे मुझसे कुछ नहीं करना. देखो 1/z है, तो 1/z what it will become, it will become e to the power of minus I. 1/z will become e to the power of minus I, and dz we have calculated t e to the power of it dt. Up, you know that whenever the base is same, exponents they add up. So
सर दूसरा हमारा EIT कहाँ से आया?
dz
नहीं.
हाँ देखो 1/z dz है ना, dz की जगह पे t e I t dt. See 1/z is the 1 upon e to the power of it, so it will be e to the power of minus it. And dz जो now we have calculated this dz how we got, differentiating z with respect to t, we get dz, and what that is what we have written. Now whenever the base is same, powers they add up. So when the power will add up, minus it plus it td, and hence it will become e to the power of 0, and e to the power of 0 is 1. And also limits we have to put, sorry I forgot that, limit is 0 to 2 pi, so we have to put 0 to 2, 0 to 2 pi, whatever limit is given, just
It will be just T, right? It will be only T dt.
yeah, it will be just t, that is. So that we know, that we are aware of, it is t square by 2. Zero to 2.
So how will be like upper limit minus lower limit? That will be 2 pi whole square.
Yeah, I will write, yeah, that is right. So it will become, see 1 by
4
2
pi
you,
square.
yeah, 1 by 2 you can take outside, and it will become, yeah, 2 pi square, so 4 pi square minus 0. The final answer will be 2 pi square. Okay, one typo we did, like blender we did, and it's good to do blender so that we understand. So when I differentiate it, it is it, not just t, because I is also a constant. It will be it e to the power of it. So I have to take it everywhere. I will be there. So it will be 2 pi square I. Oh, one more mistake. Sorry. See, differentiation of e to the power of it is just I, no? T will not be
No?
there. Differentiation of e to the power of it will be I e to the power of it. T will not be there.
Why?
Yeah, just recall e to the power of ax. The differentiation of it is a e to the power of ax. Because when you will differentiate this term, x will become 1. No? See, how you will do the differentiation of e to the power of ax? First, you will differentiate the entire function, that is e to the power of ax itself. Then you will differentiate ax, and differentiation of ax is a, because differentiation of x is 1. And similarly, differentiation of e to the power of it, when we will do first the entire function, so e to the power of it, then when you differentiate it with respect to t, it will be I, because differentiation of t is 1, isn't it?
Yes, sir.
Yeah, so we have to be very
So in
careful.
this equation, what will be removed? Like
Yeah,
this t in the second step also, not t will be removed, right?
yeah. Yeah, t will be. So it is just 1, so no 2 divided by. It will be just 2 pi.
It will be I by 2, right?
No 2, no. So you please try to do it and let me know if you are facing any problem. See, now the function you have, this is the function you have. I e to the power of
How is
minus
t
it.
cancel?
Which t? So this so after integration. See, this term will become 0. I can take outside, and integration of 1 is t.
T.
Why? Because we are integrating it with respect to t. So the integration will be t. And I am putting the limit. So 2 pi minus 0. So answer will be 2 pi I
2 pi
square.
square.
No square. Just 2 pi I. Okay. One more question. That is. In the question, they are asking us to evaluate the integral, which is something like this, contour integral for the 3z plus 1 dz. And the region, the contour C, it is given here. C is the boundary of the square. C is the boundary of the square. with vertices. With vertices. Vertices is given to us. The points z is equal to 0. Z is equal to 1. Z is equal to I plus or 1 plus I. Because square will have 4 vertices, so all the 4 vertices are given 0, 1, 1 plus I, 4 vertices. And it is given that orientation of C is anti-clockwise. Like we have to go from in the anti-clockwise direction. Orientation of C is anti-clockwise. So let us try to. So this is a tricky question.
So all these like information will be given in the question.
Yeah. This is the question itself I am writing down. All these things is given. Hmm. Now let us see how to solve this. So the first thing is that now we can visualize it because the points are given. So in the plane we can visualize it. So first let us do that. Then we will try to apply like identify or find how to solve this. So first we can make a complex plane containing both the real axis and imaginary axis. This is the real axis. This is the imaginary. Now we can get the points like given to us. So z is equal to 0 means it is like 0, 0 origin. This is one. And z is equal to 1 means imaginary part is 0, real part is 1. So it is 1, 0. And the third point is 1 plus I. It means both real part and imaginary part is 1. So 1, 1. Both of. So here it will be somewhere. And here z is equal to I. Means imaginary part is 1, real part is 0, 0. Now we can, since it's a square, then it has to be a line. No curve. It has to be a line. Something like that. And since the orientation is anti-clockwise, We can draw arrow in the anti-clockwise direction. You can draw the anti-clockwise. And we can name it O A B C. O, A, B, C. Now the integration what we have to do, ultimately 4 different integration we have to do, because here 4 curves we have, 0 like OA separately, then we have to add it with AB, then BC, then CO to get the final answer. So how we will do that, let us see. Let me do shift it so that here itself we can do properly. So this is what we have to find in the question. Integration C 3z plus 1 dz. This is what we have. This will be the integration along OA of this function. Then integration of AB plus integration of
BC.
BC. The final integration
OC.
of CO. Anti-clockwise.
Yeah.
No, here it matters because orientation
Sure,
is
okay.
anti-clockwise.
So like sir, where the direction is going, right? From
Yeah.
there we have to write.
Yeah, that is right. So this is what we have to calculate. Now we can calculate it separately and add it finally. So first we will analyze along OA. Along OA. So the equation, see OA is the x-axis and the equation of x-axis is y is equal to 0. Because ultimately we should know the equation of the curve. That is what we are doing. And here the curve is the OA line, which is overlapping with the x-axis. And the equation of x-axis is y is equal to 0. So y is equal to 0 will be the equation. And dy will also be. And x varies from 0 to 1. So the z will become because what is z? Z is x plus iy. Since y is 0, so x will be z will be x itself. What will be z will be x. See, once again I'm telling you, now what we have to do, we have to find the equation of the curve. What is the curve? What is the contour? The contour is OA. The general equation of the contour is x plus iy. And since we have OA, y will be 0. Isn't it?
Yes,
Because
sir.
the equation of this is like y is equal to 0. Because it's an x-axis. The equation of it is y 0. So the z will be x itself. So this is the equation of the contour. Now, what integration we have to do? Now we have to integrate OA 3 z plus 1 dz. Now this dz will be x itself, not x. So I will write it. See, the idea is that this contour, that is along the OA, x is the thing which is changing. So I have to find dz by dx. It will be 1. Because z is x, so the integral differentiation of z with respect to x will be 1. It means that dz is equal to dx. So now I can do this. Now what I will get? X is varying from 0 to 1. 3, instead of z, I can write x. Because z is equal to x plus 1. Instead of dz, I can write dx, which we just now saw. And when I will integrate it, I will get 3 x square by 2 plus x and the limit 0 to. And when you will solve it, you will get 5 by 2. Because, yeah, 3 by 2 plus 1. Five by. Let me write it. This way. Now we have to do the same process along AB. Let us try to do this. Along AB. Now see, AB is the y-axis. Like it is parallel to the y-axis. So x will be 0. So here x will be. And the thing which is changing is the y itself. So z will become iy. So z is x plus iy, x is 0, I. Okay. But one mistake I made. Let me see, that is right. That it is the vertical line. It is parallel to the y-axis, but since it is not origin, it is x is equal to 1. The equation is x is equal to x is equal to, because this line it is cutting the 1, not the origin, and the equation is x is equal to, and dx will become 0. because x is constant, so no change with respect to x, so dx. And y is
So why?
changing. Yeah, yeah. So
Xz will be 1 plus y, I plus y only.
no, z to we will calculate fresh. But now, like, see, AB line, it is parallel to the y-axis. And y-axis, I know the equation is x is equal to something. If this line would have been overlapping the y-axis, then the equation would have been x is equal to 0. But this AB line is not overlapping the y-axis, but it is at a distance 1 unit. And we know from the coordinate geometry, this equation, the equation of the line AB is x is equal to 1. Because it is cutting x at 1, not
No,
origin.
this I understand. I'm saying what will be the z?
Yeah, yeah, z.
Now x will be like, it will be 1 plus I by.
Yeah, yeah, that we are writing. So z will be 1 plus I by. That is right answer. That is right. Because x is 1 and I is varying. So 1 plus I by. That is right. And dz will
So it
be,
means कि अगर y की वैल्यू नहीं दी जाएगी, फिर doesn't mean कि हम उसे 0 मान लेंगे.
हाँ नहीं नहीं नहीं
से
बिल्कुल
ऊपर 0 दी थी तो हमने उसको 0 मान लिया था, सिर्फ x को ले लिया था.
नहीं नहीं yeah, see, along the OA, why we are taking y is equal to 0? Because see, OA is line, it is overlapping with the x-axis. And the equation of x-axis is y is equal to 0. If this OA, if it wouldn't have been overlapping, but वो यहाँ पे कहीं पे होता अगर, if it would be somewhere here at 1, then the equation will be y is equal to 1, not 0. Okay. And dz, when we will be doing, we will get I dy. Based on that, we can calculate the integral. Now, this is the integral we have to calculate along AB. Three z plus 1 to. So this will be integration 0 to, like the y is varying from 0 to 3. Instead of z, I can write 1 plus I by. Instead of dz, I can write I dy. It will be integration 0 to 1. 3i minus, so I square is minus 1, so minus 3y dy. It will become 3iy minus 3y square by, with the limit 0 to. It will be equal to
3i minus 3 by 2.
that is, or to be more precise, minus 3 by 2 plus 3.
Plus 3i.
Similarly, we have to calculate along BC. Now see here the graph. Once again, this BC, it is a line which is parallel to the x-axis. So its equation will be y is equal to something. And since it is not overlapping the x-axis, it is cutting the y at 1. So the equation is y is equal to 1. So for the BC, y is equal to 1. So dy will be 0, y is not changing, x is changing. So z will become x plus I. Z will become x plus I. X plus. Dz will become dx. Now we can find the integration. Integration along the contour BC. 3z plus 1 dz. It will be integration and x is here along the BC. X is varying from 1 to 0. Very important. Since anti-clockwise, so we have to take it 1 to 0. So 3 instead of z, I can write x plus I. X plus I plus 1.
Because dz by dx is equal to 1. That's why.
Sorry.
Because dz is equal to dx, that's why we are taking 1, right?
No, 1 to 3z plus 1.
नहीं सर into dz भी तो करते हैं ना.
हाँ. So instead of dz, I will write dx. Instead of dz, I will write dx. Why? Because see, when I am differentiating z with respect to x, I will get 1. So dz by dx is equal to 1. So dz will be equal to dx. And this 1 I have got because of this function 3z plus 1. So 3 instead of z, I have written x plus 1 plus. Now I can solve this.
सर ऊपर तुमने कहीं नहीं लिखा है पर.
हाँ तो ऊपर we have missed it. हाँ तो ऊपर 4i आएगा. हाँ आई थिंक आई मेड अ मिस्टेक, सॉरी फॉर दिस. तो प्लस 1 भी लिखेंगे तो वो प्लस 1 आई से मल्टीप्लाई हो जाएगा. तो 3i प्लस आई 4i हो जाएगा. मैं यहाँ पे लिख देता हूँ 4i. It will be 4i. It will be 4i. It will be 4i. The final answer we will get in 4i. ऊपर भी let us check. ऊपर सही है प्लस 1. यहाँ नहीं किया था, यहाँ पर. Okay. So now this is okay, clear. So it will be take the form like this.
It will be
Yeah. Now we can integrate it with respect to x. 3x square by 2. Let me write 2 proper. Plus 3ix plus x. 1 to 0. So 0 to everything will become 0, then minus will. So here this minus will be there. And we have 3 by 2 minus
5 by 2 plus
3i minus 2. So
so
minus 5 by,
minus square.
because limit is from 1 to 0, no? So for always we take the upper limit minus lower limit.
Oh, upper limit minus.
So minus
It
5
will
by
be
2
5
minus
by
3i.
2 minus 3i.
Minus 5 by 2 minus 3. So this is the along BC. Now we can calculate along AC last.
So
No,
CO.
not a CO. Along CA. If we look the graph for the along CO, the same thing, but now here y will be 0 because it is overlapping with the no, not sorry, y x is equal to 0.
X
So it,
will be 0.
yeah, because it's the y axis, x will be that is, along the CO it will be x. And if x is equal to 0, dz will be iy. Oh, sorry, z. Z will be iy. And dz will be I dy. Isn't it?
Yes, sir.
Now we can calculate this integration along CO 3z plus 1 dz. Integration in that direction
इसमें भी
we are
सर 1
going
to
from
0 ही जाएगा.
1 to 0. That is right. We are going from 1 to 0. And 3 instead of z I can write iy
iy.
plus 1. And instead of dz I can write I dy.
I dy.
When I will simplify this, so 3 I square is minus 1. So minus 3 by plus I dy.
So minus 3 है.
Yeah, because 3 I square y it will become na. I square is minus 1. And when you will further integrate it,
We are
Fine.
multiplying I inside.
yeah, have to. Like this I now we have to multiply with both the terms. Y square by 2 plus iy. Limit is 0 to 1 to. Now when we will put it, so 0 minus, so minus minus will become plus 3 by 2 minus I.
So where minus plus?
Sorry,
Where minus plus है?
You see, when you will put the limit, upper limit minus lower limit, upper limit is 0.
So again, that is
You will. Now we have to sum all. Whatever we have found, we have to add it up. So the final, the answer,
you have to multiply the final
no,
plus
add,
the
add,
final
yeah,
answer.
plus. So the integral, the contour integral, where the contour is the all the 4 lines, 3z plus 1 dz. It is equal to the addition of all that. So one by one we can bring it. So 5 by 2.
1 second pen pen. ഇരു രാജിത പെണ്ണില്ലേ
5 by 2 minus 3 by 2 plus
Plus
4 by
4i
minus 5 by 2 minus 3 by 2 plus 3 by 2.
so it is coming 0
Yeah, that is the right answer.
because everything is cutting like
Everything
plus
should cut.
minus is
Yeah.
there.
And that is what is we will discuss. It is a closed counter or contour, and hence it has to be 0. So this is clear. One more question we can do very quickly. Then now basically the function, the integral which we have to calculate, that is something like this: 2x plus ii plus 1 dz along the integrals I minus 1 to plus I. Here, the limits are given. Yeah. So this we have to do. So the straight away question is given and nothing else is given. So definitely 2x plus 1 plus I by will be our z. Like x will be 2x plus y and y will be y itself. Like we will do it. Now see, we know that in this equation z is 2x plus 1 plus I. And the interval is given I minus 1 to 2 plus I. So 2 points I have. I minus 1 means 0, like minus 1 comma 0. So 2 points I have. minus 1 comma 0, and one more point is 2 comma 1. So I can draw the it's clear now why how I got this point minus 1 comma 0 2 comma 1.
Huh?
How I got this point, is it clear? Minus 1 comma 0 2
No.
comma 1. No. Okay, okay, good. See, this is the question. These limits are already given in the question. Because ultimately, whenever we are drawing the graph, whatever limits are given, we have to do it accordingly. According to this limit, what are the points? Minus 1 plus I. It means minus 1 comma 1. Okay, sorry, not 0, it is minus 1 comma 1. Like the real part is minus 1 and imaginary part is 0 or 1 imaginary. So minus 1 comma 1. And second point, 2 plus I is 2 comma 1. If I plot it, somewhere here I will get minus 1 comma 1, 2 comma 1. So whenever in the question directly limit is given, so whatever limit is given, the integration is given, directly limit is given, just identify the point and merge them to get the contour. Now this is the contour we are interested in. And now we have to get the equation of this contour. So the equation of this contour will be something like this. Equation of straight line. And there are so many ways to find the write the equation of straight line. One of the way which I am following is y minus y1. Y minus y1. So I am taking 2 comma 1. So y minus 1 is equals to m x minus x. And what is for the slope? I can do y2 minus y1 upon x2 minus x. So actually it is 1 minus.
इस समय कुछ नहीं आ रहा है वो सब नहीं आ रहा है इसमें मेरे को
अच्छा तो ऐसा करते हैं this then we will do in the next from here. Is it fine? Now to
So
you are
when
in
will be the next class?
this.
So tomorrow my classes will get over at 5.